kind of need to go to Russian. Here you go. Alright.
Later.
Bro, what the zoinks? How is that even possible?
Bro, it's just a video game. It doesn't really matter. But, if you want to be explained, here you go.
Bet.
Newton's third law of motion says that for every action there's an opposite and equal reaction, meaning that there would be a great deal of force applied to Link's body as well as the hookshot itself. But how strong is that force? In order to get the amount of force, first we'll need to find the mass of the hookshot itself. So, in order to do this, we're going to find out which material it is and the volume of the actual object. So I measured it in pixels, and I found out that it's 0.0012 cubic meters. Now we need to find what material it's made out of. Since it does not rust at all and it survives extreme conditions, we're going to assume it's made out of steel. Now steel is about 8,050 kilograms per cubic meter. So we're going to multiply that by 0.0012, and we're going to get that it's approximately 9.5 kilograms or 21 pounds. So now we'll have to find out how much the chain weighs. So I did some digging and found out that at its farthest distance, the hookshot can reach about 20 meters. This would be about 0.5 inches or 1.27 centimeters thick, according to most chains. So this chain would weigh, in proportion to the hook, about 76.66 kilograms. This thing would weigh 86 kilograms put together, or 189 pounds. So now I'll plug in our mass and our acceleration to get 17,200 newtons of force. Now, it would take about 12,000 newtons to break an adult male's arm. So that is way over how much force it would take to break his arm. But as soon as he launches the thing, it retracts. Now, how much force is being applied after he's already broken his arm? Now to finish this, we'll have to find the acceleration of the hook. Now, it only takes 1 second for it to reach its maximum point, and the only time that it's accelerating, since it travels at a constant velocity, is that exact moment that you pull the trigger. Well, I did the math and found out that it only takes 0.1 seconds for it to fire after pressing the button. So we'll do 20 meters per second divided by 0.1 seconds, and this thing is traveling 200 meters per second squared. Wow. Just to put that speed in perspective, that's 10 times faster than the fastest accelerating roller coaster in the world, which is the Donpa in Japan. Many video game characters could jump once they are already in the air. This is often referred to as a double jump, and it's in a lot of video games, such as Super Smash Bros. Many of us don't question it while we play, but for those that do, here are some answers. While we would need to physically push off of the air as we're jumping back up, the air would also need to exert an equal force as us to be able to push us back into the air. So let's draw a quick diagram for our MG, or mass times gravity. Let's use Lucina as our character. Lucina is a 13-year-old girl from Fire Emblem. Let's assume that Lucina, since she carries swords and has a slim build, that she's about 50 kilograms. So if we use the equation mass times gravity, she'll have to exert a force of over 500 newtons, and we'll divide that by 0.01 seconds, which is the amount of time that she exerts this force. And she'll need about 500,000 newtons just to move in the upwards direction. Now we'll plug in some of our figures into the equation mgh to find the amount of potential energy is being gained or kinetic energy is being used to get to this height. We already said she weighed about 50 kilograms, so we'll keep that. And gravity is about 10 meters per second squared. But how do we find the height of her jump? Well, there's a stage in Smash Bros. That has meter measurements marked on the screen, and we found that she jumps about 3 meters high. So we'll plug this in, and she'll need about 1,500 newtons plus the other 500,000. So in total, she needs 501,500 newtons total to get to her height. Convert that to pounds, and that'll be about 112,400 pounds of force. Yeah, there's no way that she can jump that high, especially considering that air cannot push you up that high. There would literally need to be a force field or some kind of mass in the air that forms as she jumps.
I wonder how much force is being exerted every time that you rush at someone like that.
Well, if you really wanted to know, all we really have to do is use the equation force equals mass times acceleration. And based off of what it says online, a Big Daddy only weighs about 499 kilograms. Well, it's pretty simple. All we need to do is use the equation force equals mass times acceleration. And based off of what the internet says, the mass of a Big Daddy and his suit is equivalent to 499 kilograms. The next thing we need to know is the acceleration during the rush attack. To find this out, we need to know how far he travels, how quick he travels, and if he travels the same speed at a constant. In the game, there are 1x1 tiles, and during this attack, the Big Daddy covers 25 of these tiles. Therefore, he's traveling 25 feet, or about 7.62 meters, and he covers this distance in about 0.8 seconds, which is considerably fast for his weight. And throughout the entire attack, he travels at a constant velocity, so we can conclude that the only acceleration is in the initial step, in which the step is traveled instantaneously at 0.1 seconds. Now we can conduct the calculations. First, we divide 7.62 by 0.8 seconds, which gives us 9.525 meters per second. Then we divide this number by 0.1 seconds to result with 95.25 meters per second squared. Now that we have the acceleration, we can multiply 95.25 meters per second squared by the mass of 499 kilograms to give us a grand total of 47,530 newtons. Basically, this attack would be the equivalent of a 1,300-ton double-decker bus traveling at 9 miles per hour. You know what? I just realized Simon's been gone for a while, hasn't he?
Actually, I think you're kind of right. No
Let's
idea
go
where-
look for him.